Okay. So 0, 0, 0, 0, 1 and 0, 0, 0, 1. Okay. So, okay, can you please read the question?
Define gravitational potential at a point.
Huh. Any idea?
It's a work done per unit mass and bringing a mass from infinity to a defined point in a gravitational field.
Perfect. So it is work done per unit mass uh, in moving a mass from infinity to a point. Okay. This is the first thing. Okay. Now, please move on. Please read the question.
An isolated solid sphere of radius r may be assumed to have its mass concentrated at the center. The magnitude of the gravitational potential at the surface of the sphere is phi. On figure 1.1 show the variation of the gravitational potential with distance d from the center of the sphere for values of d from r to 4r.
Uh, yes. Any idea?
So
Mm-hmm.
it's a negative graph because phi is
Okay.
minus g and r.
Very good.
So should we start from one and then go
Mm,
lower? Like
yes.
okay, so at one it'll be at the maximum, like the lowest point.
Okay.
So on the axis basically.
So they basically mentioned that when you have the distance r, okay, so at that distance your phi will be just 1. Okay, so this is the first point that they mentioned, and that will be over here, right? Just since they mention every values on the graph, so they will expect you to draw proper graph and plot all the point. Okay, so at least they want you to show at least 3 plotted point in the graph. Okay, so the first point will be right here, and that's like mentioned in the question. Okay, so this is the first point that you have to draw. Okay. And you know that the gravitational potential is remain constant in that inside the sphere. Okay. So it looks like this. Okay. Now, what will be the second point?
2r at minus point 0.5.
Okay, so you just do the you just apply the ratio constant. You can use phi 1 r1 is equals to phi 2 r2. This is what we call the a product constant. Okay, we know one point, that is phi, and r as r, and we are working at 2r. So at 2r, we have to find out the sec 2 pi. So you can just do divided by 2 to get phi 2. So you will get, okay, very good. Okay, so that's the second point. And when you do to 3, when you go to 3r, it will be 5 by 3. Okay, when you go to 4r, it will be 5 by 4. Okay, so 5 by 3 would be how much? 1 over 3 is 0.11, I think. Yes. And
Yeah.
0.11 would be 0.25, and somewhere I think here. Okay, somewhere here. Okay, and point 1 over 4 is 0.25, 0.025. Okay, so 0.25 and 0.025, I think, would be $1, right? So your graph should move like this. Okay, right? So this is the inversely proportional graph. Okay. Acha, by the way, I also want to show you the examiner's report for that, but I don't think so for this paper. I think it won't be there because these papers didn't happen due to the corona. Okay, fine. Fine, let's move on. Okay. Okay, please read the next part.
The sphere in B is a planet with radius r 6.4 into 10 to the power 6. Excuse me. And has a mass m of 6 into 10 to the power 24 kg. The planet has no atmosphere. A rock of mass 3.4 into 10 to the power 3 kg moves directly towards the planet. Its distance from the center of the planet changes from 4 hour to 3 hour. Calculate the change in gravitational potential energy of the
Okay. And acha, by the way, what's the formula for the gravitational potential energy?
minus gmm over r.
Okay, minus GMM over R. It is May June 2020 42, variant 42. Okay. So since it is moving from 4R to 3R, so what we can do is um 6.67 exponent negative 11. Okay. And mass is 6 exponent 24. The other mass is 3.4 exponent 3. Okay. And now since we are finding the change, so what you have to do is 1 over R2 minus 1 over R1, right? So from 3R, this is the final, and minus this is the initial. Okay. And you can put in the value of R, right? So that's going to be the given value 6.4 exponent 6. Okay. Okay. And minus 1 over, and we have 4 into 6.4 exponent 6. Okay. And yep. Okay, now can you tell me the value, please?
Okay, just one second.
Meghdad, you also have to make sure that you have to be present in the classes from now on, okay? Because now we are doing the yearly passive, and okay. Whenever I mention the time, there will be 1 hour difference. I am 1 hour ahead of your time, okay? And I mentioned PM PST. PST is our Pakistan Standard Time, okay? How much? Yes.
1.77 into 10 to the power 10
Okay.
joules.
Exponent negative 10 or 10.
Exponent 10.
Okay. 1 point, we can consider 1.8, right? Because everything is in 2SF, right? Actually, by the way, it's very important to keep to give the answer in the correct significant figure, right? And over here in like A2, we don't have any standard of giving 2SF or 3SF. Okay, you have to check with the question. If everything mentioned in the question is of 2SF, okay, then your answer should also be in 2SF, right? So it should be 1.8, okay, not 1.77, okay? So 1.8 exponent 10. Good. Okay. Acha, by the way, if the rock, or if the rock is moving from 4R to 3R, meaning it is getting closer to the earth. Basically, this is the mass of the earth, by the way. Okay, so it's getting closer to the earth. Okay, so if it is getting closer to the earth, this means that the gravitational potential energy decreases. Okay, so this is basically the decrease in the gravitational potential energy that we have just calculated. Okay, so this means that its kinetic energy will going to increase. Okay, and when its kinetic energy increases, it gets speed up, right? Clear? Okay, please read the next part.
Explain whether the rock speed increases, decreases, or stay the same.
Okay, so basically every next part is connected with the previous part. Okay, so if you know what you are doing in that part that you have done, okay, then you can answer the next part easily. Okay, so that's very important. Okay, so we can say that um, since it get closer to the planet, its uh, gravitational potential energy is converted into kinetic energy. And kindly don't write this type of thing in the exam, just like ke. Okay, it's not allowed. You have to write the full form. Okay, into ke. So speed up. Okay, now it's done. Okay, please move on. Migdad, can you please read the question? Why? Eating or doing something? Bro, in yearly you have to participate. If you are not doing something, or if you're not if you're eating, even you can read if it's easy for you. Okay, fine, I'll read for you. Okay, so it's saying that um, a square box of a volume V contain n molecule of an ideal gas. Each molecule has a mass m. Using the kinetic theory of the ideal gas, it can be shown that if all the molecules are moving with a speed v at right angle to one of the face of the box, the pressure P exerted on the face of the box is given by this expression. Okay, so this is basically the kinetic particle theory or kinetic theory of an ideal gas. Okay, and okay, so this expression leads to this formula. Okay, fine. For the pressure of P of an ideal gas, okay, this is the density, root mean square. Explain how each of the following term in the equation 2 is derived from the equation 1. Okay, so there's 1 over 3 term, and there's rho, and there's root mean square speed. Okay, so for density, we can say that it is, we know that the density is mass over volume. Okay, and that is for one molecule. Okay, for a molecule. Okay, and for a gas containing an amount of molecules, the overall density is going to be rho is equals to nm over v. Okay, this is the concept right now. Okay, so we have 1 over 3. We know that we have three dimensions. Okay, and we are assuming that the particles are moving in all of the three dimension with the equal probability. Okay, and to find out the mean square value, okay, so we have to do divided by 3. Okay, moving in all three dimension. Okay, in all three dimension. uh so for average speed, it should be 1 over 3. Okay. And that is the root mean square value. Okay. So we can say that this is this is the average of the squared speed of the particles having different velocity. Different velocities. Okay. Now, they've mentioned that the ideal gas, the volume, the pressure, and the temperature, the mass is also given. Calculate the mass of the molecule of the gas. Mm. The mass of one molecule of the gas. Okay, fine. So let's first find out how many molecule it contain or how many particle it contain. Then we can find out the mass of one molecule. Okay, so we can use PV is equals to NKT. Okay, or maybe PV equals to nRT. So if I'm using that, because I just want to have a number of molecule, so the pressure is given as 3 exponent 5. Okay, and the volume is 6 exponent negative 3. Be very careful with the volume because sometime they mention the volume in centimeter cube. Okay, so but for now it's like fine. Okay, and now the n is the number of particle we're interested in. Okay, and the k is the Boltzmann constant, so 1.38 exponent negative 23. Okay, and the temperature has to be in Kelvin and it is in degrees, so you have to do 273.16 or 273 plus 17. Okay, so from this you will get the number of particle, and please also always write the equation first. Okay, whatever you are calculating, write the equation first and then start calculating. Okay. So I'm getting the number of particle as 4.497 exponent 23. Okay, so this is the number of particle I have. Okay, and I don't know the mass of one particle, mass of one particle. Okay, this is what I want to know, but I know that the mass of the whole gas. Okay, and mass of the gas is what we know, that is 20.7 grams. Okay, and it corresponds to 4.497 exponent 23 particles. Okay, negative 23 particles. Okay, so to find out the mass of the one particle you just need to do cross multiplication. Okay, and you'll get the mass. Okay, so 20.7. Okay, and they're asking in grams, so you don't have to convert it into any other thing. 4.497 exponent negative 23. Okay, so I am getting 4.6, and now everything in 2SF. So I am writing my answer in 2SF as well. 4.6 exponent negative 23. Okay, fine. That's it. Okay, we move on. Ivan, please read the question.
Okay. By reference to the first laws of thermodynamics, state and explain change, if any, in the internal energy of a lump of solid lead as it melts to constant temperature.
Okay. Acha, what's the first law of thermodynamics?
U is equals to Q plus W.
Okay, plus W. Fine. Okay, so if it says that it's a constant temperature, so this means the change in temperature is going to be zero, right? And if the change is zero, then Q will also be zero, right? Because Q is related to the change in temperature, right?
Yeah.
Okay, and but since we have um, as it melts, okay, so if it is melting, then this means the temperature is not rising, but the heat is still being supplied because we have the temperature change, right? We have the state change, right? So the Q shouldn't be zero, right? Q shouldn't be zero because the heat is consumed into the bond breaking, right? So yes, okay, so it should be Q should be positive, right? First thing. Now second thing is um if it is converting from solid to liquid, we assume that there isn't any change in the volume. So because generally when state change happens, we assume that there is a very less amount of change in volume. Okay, so okay, so we can say that in state change, the change in volume will be very negligible. Negligible. Okay, so work done will be zero. Just a minute, please. Okay. So work done, right? This is the first point. Now the second point is uh, heat is consumed in bond breaking. Bond breaking. Okay. So this leads to the increase in internal energy. Internal energy. Okay. And these are the three quantities, and you'll get the 3 marks for three quantities. Okay. Please move on.
Some gas in a toy balloon when the balloon bursts and no thermal energy enters or leaves the gas.
Okay. If it is bursting, what will happen with the volume?
Volume will increase.
Okay. So volume increases. Okay, so if the volume increase, what does the gas have to do against the surrounding? Will it do the work done on the surrounding, or will the work done work will be done by the surrounding on the gas? Yes.
I think it's by the surrounding on the gas, but I'm not entirely sure.
No, by this, if it happens by the surrounding on the gas, then the gas compresses, right? Because every surrounding compresses the gas or pushes the gas inward, right? But if the balloon is bursting, this means that the gas inside the balloon is doing the work done against the surrounding, and it pushes the surrounding away, right? Sense? Making sense? Right?
Yes, so
And
then
if yes, then the
the
work
work
done
done
will
is
be
positive,
negative. Negative.
negative. Okay.
Because it goes out, right? Because the work done from the gas will go transfer into the surrounding, because it like all the work done is utilized in that, in pushing the surrounding outwards, right? So it decreases. Okay. And okay, so and they're saying thermal energy, no thermal energy is enter or leave the gas, so this means Q is going to be 0. Okay, so we can say that no heat is supplied or removed. Okay, and um, during burst, during burst. Okay, I can say that um, the gas expands. Okay, and work is done against the atmosphere or surrounding atmosphere. Okay, so the internal energy decreases, right? Clear? Okay. Acha, there's one more scenario that they can ask. Okay, because in both of the cases we have one thing zero, like in the previous case, the work done is not changing. Okay, and in this case there's an heat supply. But what if both of the things happen together, like the volume changes and the heat supply or heat remove as well, right? So in that case you have to say that if the volume change is greater than the heat change, then it will be the internal energy increase, right? Okay, and if the volume change is smaller than the heat change, then the internal energy will be decreased, right? Because if like when they both happens at the same time, when they both happen at the same time, when the change in the volume and the change in the heat happens at the same time, so this will always be in the negative and this will always be in the positive. Okay, or the other way around. Okay, if this will be positive then this will be negative, and if this will be negative then this will be positive, right? Both can be similar at the same time, right? So yes, you can say that if such type of question appears. Okay, now we have simple harmonic motion. Okay, Megdad, can you read now? Yes, Q is heat.
Yes, sir.
Okay, please read. Yes,
A
where are
dish
you?
is made from a section of a hollow glass sphere. Hori- Horizontal table contains a ball of mass 45 grams as shown in figure 4.1.
Okay,
The placement of the ball from center C of the dish is with distance x at 3.0 centimeter. The ball is then released with the variation of with time t of the horizontal dis displacement x of the ball from the point C is shown in figure
okay,
4.2.
fine. They mentioned everything. Okay, what the question saying?
Use figure 4.2 to show that the angular frequency of the oscillation of the ball in the dish is 2.9.
Okay, what you can do in this question? Yes, any idea? From the figure, you can have two things: the amplitude and the frequency, the time period. Okay, and the time period is it's right here. Okay, So the time period is going to be, okay. It is 2.2
2 pi by t.
2 pi. Okay, very good. So we know that omega is 2 pi by t and 2 pi over. Acha, by the way, they're saying show that. So please mention separately that the t is 2.2. It's better um to say it separately because they're saying show that and show that question. They give you mark like when you write everything. Okay, so now do the solution. 2.2 and yep. What's the answer? It is 2.85.
855.
Okay, but you have to give it in 2.9, so just 2.9, and that's omega. Okay, now they're saying determine R. Okay, yes, Migdad, can you tell me any idea or anything, any concept that how we can find out the R, this R?
You make omega
Okay,
equals to g by r.
G by R. Okay,
Yeah,
and why is that? Any reason for that?
because of the formula, no?
Okay,
It's
so
minus
basically
omega x.
what they're saying is it follow the simple harmonic motion, and the formula for the simple harmonic motion is actually A is equals to omega is squared, not omega actually, x naught, right? Or x with a negative sign. Okay, so for this setup or for this system to be in the simple harmonic motion, this whole thing should be equal to omega square. Okay, not omega. Clear? So very good. Okay, so you can say that g over r should be equal to omega squared. Okay, and g is 9.81 divided by 2.9 squared, and that is going to be your r. How much? Yes, I'm getting 1.202. Are you guys getting the same? Okay,
I'm getting 1.166,
one
which is
six.
basically 1.2.
Okay, fine. Okay, that please read the next part.
Calculate the speed of the ball as if the passes over C of the dash.
Okay, the center of the Z. Okay, so can you tell me what will be the speed at C? Will it be maximum? Will it be minimum? Will it be in between? Yes,
Maximum,
very good. And any reason for the maximum? Because it's a mean point, right? Right.
yeah.
So
Yes.
at the mean point, we have the maximum speed, right? So for the maximum, we have the formula x naught omega. Okay. We can have the amplitude from the graph that is 3. Okay. And I think it's centimeter. Yep. 3 centimeter, -2, and omega is 2.9. Okay. So how much is the velocity? Yes. I am getting 0.087.
Yes, I'm getting that as well.
Okay. Okay, with that, please. Need the last part.
The moisture collects on the surface of the dish so that the motion of the ball becomes lightly damped on the axis on figure 4.2. Draw a line to show that the lightly damped motion of the ball for the first 5 seconds after the release of the ball.
Okay. It is basically lightly damped, okay? And you should know how to draw the light damping graph. Can you tell me, please? Yes. For guess me that for the 5 seconds. Here till here.
It
Okay.
should become lower and
Amplitude.
lower after time. Yeah, the
Okay.
amplitude.
You have to start from the same point. Okay.
Yeah, yeah.
And okay, now can show the lower amplitude. Come on. Okay. And the time period should be approximately the same, right? And right. So for this, you get 3 mark. Okay. Perfect. Okay. This is how it looks like. Okay. Good. Okay. So principle of detection of the ultrasound. Do you guys know how the ultrasound get detected?
No, sir.
No. Okay.
The
No idea.
the thing is, I'm struggling with this. Like medical physics is quite hard because it's more theory based,
Yep. Okay. Now listen. Basically, most of the
at
exam
least for
they
me.
give the same type of thing or same type of questions. Okay. So okay. Now if they're saying detection, we have the transmission, we have the detection, and we have the imaging. Okay, these are the three 6 mark or 4 mark question you can expect in the exam. Okay, so for now it's a detection. So in detection, what you can say that like imagine that you have this surface and you're sending the ultrasound pulse in. Okay, and there's like another thing inside the surface, right? So some of the ultrasound, those who get transmitted in, will get reflected from the end, okay, and back, okay, get back onto the detector, okay. This is the first thing. Now, on the detector, you have like the transducer, you have the crystal, okay, that receives the ultrasound, okay, and it convert that ultrasound into electric signal, okay, and that electric signal is basically received on like in the machine, and this is how you detect the ultrasound, okay. So what you have to write is, I will provide my note of all the the medical physics. Kindly go through them. Okay, they're like mainly memorization thing. Okay, and it's not that much of like conceptual thing. But if you guys say, then we'll do one class. We will go through all the the medical physics. Okay, so ultrasound pulse get um, reflected from the boundary. Okay, and it get detected in the or on the transducer, on the transducer, where the the quartz crystal or piezoelectric crystal received it and it um start oscillating, okay, which convert the ultrasound into electric signal, or EMF signals, okay, and that electric signals get detected, okay, for further investigation, okay. Now this is like the 4 mark thing, okay. Now they're saying by reference to the specific acoustic impedance, okay. So the specific acoustic impedance is basically the impedance, the it is like the resistance for every medium or for every organ towards the sound. Okay, so when you let the sound move through any medium, okay, so if it's like the stiff or the rigid medium, then does not let the sound to pass through, right? And sorry, it's basically let the sound to pass through, but if it is a liquid medium, then it does not let the sound pass through, and if it is gas medium, then there will be very least sound flow, right? So this is what the specific acoustic impedance mean, okay, and it has a formula, Z is equals to PC, okay, Z, which is a specific acoustic impedance, and rho, which is the density of the medium, times C, the speed of the sound, not light, okay, speed of the sound in that medium, okay. So explain why there is a very little transmission, okay, from air to skin, okay. So we have air and we have skin, okay. There are two things or two medium we have, right? So if you want the maximum transmission, okay, then the two medium should have the same specific acoustic impedance, right? This two medium should be of the same type if you want the maximum transmission, right, to take place, right? And if there is a very
Understood.
sorry, bolo, yes.
Yeah, sorry to interrupt, but you said that it
Mm-hmm.
should have like the same, like close to similar values in specific acoustic impedance, right?
Yes.
So there's like some gel, right, that they use
Yeah,
like
yeah, yeah.
for.
If you want, like if they ask you how to increase the specific acoustic sorry, if they ask you how to increase the maximum transmission, okay, then you can say put any gel or anything that has the density or specific acoustic impedance closer to the skin value, okay, and then start transmitting the ultrasound through that, so it will make sure the maximum transmission, okay. Is that clear, guys?
Yeah.
Good. Okay, so we can say that the specific acoustic impedance for air and skin are very different. Okay, so maximum ultra sound pulse get reflected at the air skin boundary. Okay, so minimum transmission. Okay. Now, okay. Meghnad, can you please read the question?
A metasphere of radius r is isolated in space. Point P is a distance x from the center of the sphere illustrated in figure 7.1.
Okay,
The definition of a distance x of the electric field strength E due to the charge on the sphere is shown.
fine. Okay, so the Acha, can you tell me by looking at the graph, can you tell me the radius of the sphere? Yes, Meghnad.
Uh,
We know that inside the sphere, the electric field remains zero, right? So
yeah,
till that point where the electric field is zero, that will be the radius, okay? Because this is the center, okay, and this is the surface, okay?
also
So this is the radius, okay? That is going to be 4 point, I think this is 5,
5.
4.245, okay, 4.5. 4.5, okay. What is meant by the electric field strength? Yes, can you define?
Force of charge.
Okay. But it is basically force per unit positive charge, not just charge, okay? Because you have to make something as a standard, okay? So the scientists make positive charge as a standard, okay? So because we have two charges, okay? So how can one understand which charge we are talking about, right? So this is the concept, okay? If you just write force over charge, then you'll get 1 mark. Force per unit positive charge, you'll get 2 marks, okay? Okay, please move on.
Use figure 7.2 to
Yes,
determine the radius r of the sphere. Explain your work.
we can say that it's 4.5, right? Because we just worked out for that, right? But you won't get mark if you just write a 4.5. They're saying explain your working, so you have to say the electric field inside the sphere or inside the conducting sphere should be should be zero till the surface. Okay, this is the explanation, and then you can write the answer directly. Okay, moving on to determine the charge on the sphere. Okay, so we can have our electric field from the graph, which is 15, 17, 18, right? And it's exponent 5. Okay, be careful with this. Okay, so we know that the electric field formula is E is equals to KQ over R, or you can also use E is equals to 4 pi epsilon naught R, right? So the electric field is 18 exponent 5, and the radius is 4.5, and this is squared, okay? Exponent negative 2 whole squared, okay? And divided by the k, which is 8.99. This is a constant value, by the way, exponent 9, and that is k, okay? And we have okay, q. How much is the q?
सर के किसकी कांस्टेंट वैल्यू है, लाइक इसका नाम क्या है?
इलेक्ट्रिक फील्ड कांस्टेंट पेपर के शुरू में गिवन होती है. Yes, how much?
सर 9 एक्सपोनेंट माइनस 6.
9 एक्सपोनेंट माइनस 6. इसको स्क्वायर नहीं किया मेरे ख्याल से आप लोगों ने. आर स्क्वायर किया. इनका कुछ और आ रहा है.
4 एक्सपोनेंट माइनस 7.
हम्म सही. So it is 4.0 exponent negative 7. सही. Okay. Yes, with that, can you please read?
And alpha particle is situated a distance 8 centimeters from the center of the sphere, calculate the acceleration of the alpha particle.
Hmm. Yes. So can you guys relate any formula that is like you can use it for the acceleration? Basically, for the acceleration, if I say the resultant force equals ma, okay, and over here the resultant force is only in the form of electric field, okay, so this resultant force can be the electric force, okay, and so an electric force as a formula um, of electric field over charge, sorry, uh, or basically, mm, yes, okay, it should be electric fields time charge, okay, so this is the formula for the electric field, okay, and the electric force times the electric is equals to the electric field times the charge, okay, so the electric field is what we know or not don't know. So it is 8 centimeters. So we have to find out the electric field at the 8 centimeter. Okay. So it is right here. So the electric field is 5. Okay. That is 7.5. Okay. So 6 point, I think 5.5 and then 6. Yep. Approximately 5.5, 5.75 would be. Okay. So the electric field, so E is 5.75, okay, exponent 5 taken from the graph when the distance x or r is 8 centimeter from the center, okay, and fine, okay, now okay, I can put it over here divided by m, so that will give me my acceleration, okay. Now the electric field is 5.75 exponent 5, okay, this is the first thing. The charge has a value of the alpha particle has 2 plus of charge, so 2 times 1.6 exponent negative 19, okay, this is the charge divided by the mass, okay, and the alpha particle has 4 unit or 4 unified atomic mass, 4 into 1.66 exponent negative 27, okay, so yep, so please calculate the value.
सर ये वाला सवाल फिर से समझा सकते हैं?
समझा देंगे, पहले वैल्यू तो बताओ। Is how much?
Sir, 2.77 exponent 13.
Okay, so 2.77 exponent 13, right? Which would be 2.8 exponent 13. देखो concept ये है कि they're saying that you have the sphere जिसके ऊपर charge है. So you have a bigger sphere that causes the electric field, right? This one. So this is the bigger sphere that causes the electric field, okay? And let's say I have this point P, let's say, where we have the alpha particle, okay? And let's say the distance, because they mentioned the distance as 8 centimeter, 8.0, right? Clear? And they're asking the acceleration of this alpha particle, okay, at this point, which is 8 centimeter, right? The question is this, right? Question समझ में आता है? Is the question clear?
Yes, sir.
Okay. Now, so you can use a graph at 8 centimeter to find out the electric field uh, at that point. So which is the electric field is 5.75 exponent 5, right? This is the electric field, the corresponding electric field. Okay. Now, to relate the acceleration and the force, I can say that the resultant force is equals to ma, right? Is that clear?
G.
And over here, there isn't any other force except the electric force, because this is like the whole setup is the electric setup where you have the charge and the charge experiences the force, right? So you have only the electric force experienced by that alpha particle. Okay. So I can also say that this resultant force can also be Fe only, which is the electric force, okay, equals ma, right? And the electric force has a formula equal to electric field times charge, the value of the charge, right? So over here we have the alpha particle, so its charge is 2 times of the electron, right? So I just replace this with eq equals ma, right? ये समझ में आता है?
G, sir.
And then just make eq over m as a subject and आपके पास आ जाएगा a, right? So now the electric field is what we have taken from the question, the graph. The charge of the alpha particle is 2 times the charge of the electron, which is 1.6 exponent negative 19, and the mass of the alpha particle is 4 times the unified atomic mass, which is 1.66 exponent negative 19, okay, negative 27, okay. So you just need to put in the value and solve, right? समझ गया?
G, sir.
चलो that's done. अच्छा देखो, फ्रॉम लाइक
मैथ्स
एनी,
वाला पीसीसी बनाएंगे एक सेकंड, आपको मैथ्स पे कहाँ से आया था?
देखो अल्फा पार्टिकल का जो चार्ज होता है, अल्फा पार्टिकल का जो चार्ज होता है वो 2 प्लस का होता है, और अल्फा पार्टिकल का जो मास है वो 4u का मास है, राइट? हीलियम पार्टिकल
सही
होता है
होता
अल्फा पार्टिकल, सही। सो यू जो है वो आपकी वैल्यू उसके पेपर के शुरू में गिवन होगी 1.66 एक्सपेंट नेगेटिव 27, ओके। Acha. So any question that contain this sort of thing is now excluded. Okay, it is basically the chapter of electronics, which is the part of the syllabus before 2022. Okay, so it is not included right now, so you can skip these type of question. Okay, and also anything regarding the communication. Okay, like the fiber optics. Okay, and the decibel, you can also ignore that because it is also in the syllabus before 2022, and then it is like skipped. Okay, so you can skip this one as well. And the third thing is the band theory. Okay, this is also like removed from the syllabus. Okay, at the same time. Okay, now we have the magnetic field. Okay, can you guys please read the question? Yes, Irfan, can you please read the question?
Yeah, okay. An electron is traveling at a speed v in a straight line in a vacuum. It enters a uniform magnetic field of flux density 8 into 10 to the power minus 4t. Initially, the electron is traveling at right angles to the magnetic field, as illustrated in 9.1.
Okay. Acha,
The partially
can I have a little break for namaz of like 5 minutes maximum or 10 minutes? Okay. You kindly read the question. So it says state and explain the direction of the magnetic field. Okay, fine. So what you have to do is you just need to use the Fleming's left hand rule, and you have to make it as a reference, and you have to define everything, right? So it's a path of the electron, and you know that this is the Fleming's left hand rule. And over here, the second finger shows the path of the positive current or positive charge particle flow. Okay, so we can say that um using Fleming's left hand rule, the current should be from right to left, right to left, okay, which is like the opposite direction of the flow of electron. And they mentioned the magnetic field. Okay,
into the page.
where? An electron, the internal uniform flux density. Okay, fine. We have to. Okay, fine. The force is basically acting downward, right? Like in this portion. So using that, yep, it is or so we can say that the force is downward. So field should be into the page. Okay, please move on. Next part.
So that speed v of the electron is 9 into 10 to the power 6 meter per second.
Hmm. So,
Uh,
okay, yes, the radius is given, the magnetic field is given, so you can use,
mv
uh,
square
okay, but before that, FB, which is the magnetic field, is equals to BQV,
centripetal
BQV,
force.
right? And I can also say that magnetic velocity, the field is, we don't have the force by the way, okay. So we can say that uh, magnetic force, since it's a show that question, so you have to write everything. So magnetic force provide centripetal force, centripetal force, okay, to the electron, okay. So Fc is equals to mv squared over r, and we can equate that. So F B, which is a magnetic force, is equals to oh sorry, BQV, and instead of, sorry, mv squared over r, and in FB I can put BQV is equals to mv squared over r, okay. So v and v squared get cancelled, okay. And we have to find out the velocity, so you have to show each and every step, okay. You cannot skip any of the step, okay. 8 exponent negative 4, so it's 8 exponent negative 4. The charge of the electron is 1.6 exponent negative 19, and you have the radius as, it's the radius or the diameter, okay. The radius is 6.4 exponent negative 2, and we have the mass of the electron as 9.11 exponent negative 31, okay. And this will give you your velocity. Yes, how much?
It's 8.99 into 10 to the power 6, so that's just 9.
Okay,
90.
so okay, so you are saying 8.99 exponent 6, okay, good. Okay, please move on.
A uniform electric field is now applied in the same region as the magnetic field. The electron pass on deviated through the regions of the two fields, as illustrated in figure 9.2.
Okay.
On figure 9.0, mark with an arrow the direction of the uniform electric field.
Hmm. Any idea? By the way, yes, the electric force in the previous case was acting downward, okay. This was the electric, not the field, the electric force, okay, which was acting downward, that causes a electron to bend downward, right?
Yeah.
And okay, so in which direction should the electric force act in order to nullify the effect? What do you think?
Upwards.
Upwards, very good. So electric force, not field, electric force should be upward, right? Now we know that the direction of the electric force and the direction of electric field are both same, while the direction of magnetic force and the magnetic field are perpendicular to each other, right? So you can say that the electric field should also be upward. Okay, so okay, so basically this is the direction of the electric field. Okay, okay, please move on. Field strength. Okay, so we know that um, electric and magnetic forces are equal and opposite on the charged particle, right? That does not mean it is following Newton's third law. It is basically Newton's first law because there's only one particle. Okay, and so we can say that electric field is EQ, electric force is EQ, and BQB is a magnetic force. Okay, so E, the electric field strength, is the product of the magnetic force, which is 8 exponent negative force 4 times the velocity, which is 8.99 exponent 6. Okay, how much?
So,
Mhm.
when you're doing these sort of questions where you have to like, it's saying use the data, right? So
Mhm.
do we, the original formula is there that V is equals to E upon B. If we
Mhm.
just use that, will we get marks, or do we have to show that it's like equal to each other and all that?
For now, like for this question, you don't have to show anything. Like if you can if you can go directly E over B is equals to V, then you'll get the mark. But if in the question they ask you to show that this thing, or to they ask you to drive this thing, then you have to show everything, right?
Yeah, okay.
But it's better to be on the safe side by showing everything. So yep, that's why I show.
Okay.
I think 72 around 7.2 exponent something, because 8 into 9 72, and negative 6 negative 2.
7.2 into 10 to the power 3.
Okay, fine, please move on.
The electron in B is now replaced by an alpha particle traveling at the same speed v along the same initial path as the electron. Describe and explain the shape of the path in the region of the magnetic and electric field.
Hmm. Traveling with the same speed, this is very important.
So we should use the Fleming's left hand rule, right?
No, no, no,
No.
no. Fleming's left hand rule is only for the magnetic field, right? But over here, we have the similar electric and magnetic field, right? And if you have the electric and magnetic field, then if you relate electric field and magnetic field is equals to V, right? So the point is, when you have this sort of concept where you have the electric field and the magnetic field, they are normal to each other, and the electric force and magnetic force are opposite to each other, right? So in those type of constant, only the velocity is the factor that affects the direction, okay? And there isn't any other parameter that affect, okay? So over here, the alpha particle basically have twice the charge of the electron, and it is going to be the positive, right? So this is the first thing, and the second thing is um the same velocity. Okay, if the velocity is same, then it will go undeviated. Okay, because in this type of concept, only velocity is a factor that like causes a change, right? So we can say that um it pass it pass undeviated. Okay, as the velocity is the only factor affects the velocity is the only factor um affects the deviation. Okay. Okay. Electromagnetic. Okay. By the way, transformer is also not a part of syllabus anymore, so you can ignore the transformer concept. Okay. Yep. But you can say the electromagnetic, the Faraday's law of the electromagnetic. Yes. Can you recall the Faraday law of electromagnetic induction? The
Okay, 1 second.
induced EMF is directly proportional to the rate of change of magnetic flux linkage. Linkage, right? This is the concept. Okay. And say it's basically it does a step up and step down function, right? And use the Faraday law to explain the output transformer as an electromotive force that is alternating. So you can say that it's basically somewhat related to the concept of induction and also not a part of syllabus because of the tra transformer. But since it's an application, so I'll just tell you the answer and move on, right? Okay. So over here, what you have to do is, or what you have to say is, the input in the primary coil causes the EMF to be causes the magnetic field to be generated in the primary section, okay, which is linked through the core to the secondary section, okay, where it get cut, like the magnetic field get cut and the EMF induced, and since the primary is changing, so the output is also output will be changing, right? So yeah, this is like the concept, right? So fine. Chalo. Let's move on to, okay, band theory is also not a part of syllabus, so you can ignore this one. Okay, now the last question. Okay, very simple. So they're saying what is meant by the mass defect? Yes. Any idea? Is basically the
I'm not really sure of this definition for now because like I have to revise this chapter.
okay. So it is basically a difference between the mass of the nucleus, okay, and the mass of their um, constituents when they are at infinity. What does this mean? This means that if, like, imagine a sodium atom, okay? The nucleus of the sodium atom weighs 23 point something something, right? And it contain 11 neutron and 12 proton, right? No, the other way. The 11 proton and the 12 neutron, right? Now, so whatever its existing mass is, that's basically 23 point something something. And if you find out the individual masses of like all the proton and the neutron separately, and then you combine them all, okay, so you will find the difference between its existing mass and the calculated mass, okay, and when you subtract the two masses, you'll get the mass defect, okay, and that is basically that mass that we're talking about here, right? And this definition is very simple, very easy. Okay, now they're saying the energy equivalent to this much. Okay, it's a very simple thing that you have to show, that is basically equals to mc squared, and we know that 1 u is basically equivalent to 1.66 exponent negative 27 kgs, kgs of mass. Okay, so just put that into the mass. Okay, and the speed of light, that is 3.8 squared. Okay, and this will give you the energy in joules. You have to convert it into mega electron volt. So to convert it into mega electron volt, 1.62 exponent negative 19, and for the mega exponent at 1 exponent 6. Okay, so you will end up getting 933 point something 75 or 1934. Okay, 933 33.75 or 934. Fine. Now, over here, binding energy per nucleon of the helium is given as this. So, like, you have to show that, okay? Now, they mentioned the helium nucleus, okay, with its mass as well, okay? So, and they also mentioned the mass of the proton and the mass of the neutron, right? So, the mass defect is basically the difference in the mass, the difference in the existing mass and the calculated mass, okay? So, the calculated mass is going to be the mass that we are calculating is basically 2 proton and times it by the mass of the proton, which is 1.007267 so okay, 7276. Okay, this is the mass of the proton plus 2 times the mass of the neutron, which is 1.008665. 1.008665. Okay, this is the calculated mass of the helium. Can you please calculate the value? Yes, how much? Yes, how much?
4.031882.
Okay, 4.031882. Okay, this is the calculated mass. Okay, and you have the actual mass, the existing mass. It has a value given 4.001506. So 4.001506. Okay, this is the existing mass. Okay, so to find the mass defect or delta M, what you have to do is you have to subtract the two masses. Okay, you have to just subtract these two masses. Okay, and tell me the value, please. This is the mass existing. Okay.
0.030376.
Okay. So that is 0.030376, and it is in the form of U, right? Now, in the previous part, we have calculated that one U is basically 934, right? So we know that one U corresponds to 934. So if we have 0.03076 U, so how much will it be? Yes, just do the cross multiplication. That gave you the binding energy.
29.6.
Okay. Okay, energy. So it is basically 29.6. Okay. But they're asking for per nucleon. Okay. And we have how many nucleons in helium? 4, right? So just divide that by 4. So I'll get per nucleon. So binding energy.
7.4117.
7.41.
Yeah.
It should be 7.09, but okay, fine. Let me 0.03076. Okay, that's correct. And okay, fine. 0.0, it should be 7.07 because wait,
So is this the marking scheme onto that you're checking?
yes. Let
Did
me mm,
when you do the cross multiplication, there's 0.030376, not 76.
0.03. Okay, okay, fine. So it's my mistake. 0.030376. Okay. Okay, and divided by 7. So, sorry, divided by 4. So 9.02. 28 point is basically 28.371. Okay. So 7.09. Okay. Last part. Yes.
Isotopes of hydrogen have different binding energies per nucleon less than 3 mega electron volts. Suggest why a nucleus of helium-4 does not spontaneously break down to become nuclei of hydrogen.
Hmm. Acha ji. So for the binding energy per nucleon of the helium, it is like much greater. Okay. And it is like approximately towards the stability. Okay. So this required, like the helium required a lot of energy to break or to be broken. Okay. So it does not break itself or spontaneously, right? Clear?
Yeah.
Okay. So we can say that uh, the binding energy um, per nucleon of helium is much greater, which means it required a lot of energy to break. Okay. And fine. That's it. Okay. So the paper is completed. Okay. Now, um, which paper you did yesterday? 41, right?
Let me just check and tell you. I
Yeah, yeah,
wrote
yeah.
it.
It
June
was
2019, 42.
okay, fine. So now you have to do June 2020 and 41. Okay, this is the homework. And kindly mention it in the group, please.
Okay.
Okay, sure. That's it. Okay, take care. Love is.
Left is.
Love is.